Student, today we will learn the chapter Determinant Part 4, Part 5. Today I will tell you some important points. After that I will tell you solving of the linear equations by matrix method. Okay. So the important point is this: if you want to evaluate a determinant of order 3 into 3, evaluate of order 3 into 3. Let, with the help of the examples, we will do it. You can evaluate this by any row or any column, but for order of only 3 into 3, I am telling you a method that is known as the rule of series. Using the rule of the series, we can evaluate of this determinant in a very easy way. And what is the easy way? First, you have to multiply this. First multiply this. Okay. Then write this 3, 6, minus 2 first column here and second column here, minus 2, 1, minus 3, and then you have to multiply this and you have to multiply this and add it. Okay, so we write here what we have got it: 3 into 1 into 2 plus minus 2 into minus 1 into minus 2. Okay, and then plus 2 into 6 into minus 3. First multiply it by this way, and then you can multiply this arrow and then this arrow and this arrow, then subtract it. Now minus 2 into 1 into 2, and then minus 3 into minus 1 into 3, and then minus 2 into 6 into minus 2, and then you can solve it. You will get the value of determinant. This method, series method, can be used only for 3 into 3. Okay, so it is easier for you if you want to use this series method, right? So solving this, what we get, that is your answer: 3 into 1 into 6, and then it is minus plus minus 2 into 2, 4, minus 4, and then it will be 2 into 6 into 3, minus 36, and then this will be minus plus 4, and this is for you what is minus into minus plus minus 3 into 3, 9, and last is plus 6 to 5, 12, 24, So total is minus 15, and this will be your required answer. Using this Cyrus method, you can benefit for 3 into 3. Okay, student. So for the next point, I am telling you some more interesting things. So now it is always a confusion to the student that if there are two matrices AB equal to AC, is we can cancel out A. There is a use of the cancellation law. We can cancel A and then B equal to C if A, B and C are two matrices. Okay, student. So student, we can So student, cancellation law AB equal to AC, can we cancel A equal to A? We cannot cancel it. Okay, student. Now cancellation law for the multiplication of real number is not valid for the multiplication. So you can note this point. Cancellation law for the multiplication of real numbers is not valid for the multiplication of matrix. Okay, we cannot cancel this and we cannot write AB equal to AC. Then it does not apply that B equal to C, does not. Okay, listen here. Now this we can understand by an example. Let we have A is 1 2 0 1 1 0 minus 4. Let here is minus 1 4 0. Let B matrix is 1 2 3 1 1 minus 1 2 2 2, and let C is, for example, 1 2 3 1 1 minus 1 1 1 1. And now when you find it AB, you can do the product yourself, and AC you will get both will be equal 3 4 1 2 3 1 3 2 minus 7. This you can check yourself by doing the product. Okay, now we can see AB equal to AC, but B equal not to C. B equal not C. Okay, and A equal not 0 matrix, and B equal not C. I am saying A equal not 0 matrix, not I am saying the value of A is 0. Okay, so this you have to understand, right? Now I am telling you some more one things, that is a very important theorem that if A and B are two non-singular matrices of the same type, then adjoint AB equal to product of adjoint A and adjoint B and adjoint A. This law you have to learn better. Okay, now I can give you proof of this. Since we know that product of AB with adjoint AB, we can write determinant of AB and I. Okay, so we can also write is also add product with adjoint A with product with AB. Right, now we can write this in this way. Now we can this write here AB into adjoint B into adjoint A. Okay, now we can write this A into B adjoint B adjoint A, this bracket. Okay, understand? Then we can write A, the value of this is determinant B adjoint A. Okay, now we can write this determinant B A adjoint A, and again we can write this determinant B and determinant A I equal to determinant A determinant B I equal to determinant of ABI, product layer of determinant. Okay, so we can write this AB adjoint AB. Okay, student. So since AB equal to AC, cancellation law we cannot use, so again we can write this way. It implies that adjoint B into adjoint A equal to adjoint AB. Okay, so this formula you can use better. So both sides AB cannot be using the cancellation law. Okay, using the cancellation, AB equal to AC does not necessarily imply B equal to C. However, ABC are square matrix of the same type, and if A is non-singular matrix, then AB equal to AC, then B equal to C. So the important point is that we are not using their cancellation law, right? But however, the square matrix of the same type, and if A is non-singular matrix, then AB equal to AC. It is the conditions, so we can say this formula. right student? So now we are explaining the next point, a very important point for all of you, that is if we know the B inverse, we can find equal to B inverse A inverse. Reversal law for the inverse of a product, and this is known as reversal law for the inverse of a product. For the inverse of a product. Okay. Now second point is, if we want to inverse of a transpose, we can also find the first inverse then transpose. Okay, this is a very important point. You will use this in so many questions. So before going to the next part, I want to tell you this point you have to learn. Okay, so student, now I am telling you application of matrix to solution of linear equation. Okay, now application of matrices to the solution of linear equation and this is known as matrix method or Martin's rule. Martin's rule. Okay. Now, why we are using the chapter matrix here in the chapter determinant? Because so many points we are using the determinant to solving the linear equations. Okay, determinant will be used to solving this equation by Martin's method, but it is known as the Martin's rule or matrix method. Okay, and now you know well in the starting what I have explained, that we can solve the linear equations and how we got it. So I am revising it. Let a1x plus b1y equal to c1 and a2x plus b2y equal to c2. These two equations you have to solve. So we can see this coefficient if we write here a1, a2, b1, b2 in a matrix. Okay, and product with this matrix, so we can multiply a1x plus b1y, we get this one, and similarly this one. So we can find this is equal to c1, c2. So this equation can be write in this form. So if we write is ax, we denote it by b. So how we will get the value of x and y? Okay student, so we can get the value of x and y by this way, that ax equal to b, and now we multiplied by a inverse both sides. What we get? A inverse ax equal to a inverse b, then it is ix equal to a inverse b. So x equal to a inverse b, And what do you know in the matrix method, that is 1 upon determinant A. So we are using determinant. So this lecture I am taking in the chapter determinant. Okay, and product with adjoint A and B. So but how we can, when doing this solution, adjoint A we know and product also know, divided by this determinant we can compare the x and y. Okay student, now you should understand, if this value is 0 or equal not 0, what happened about this? If this value is 0 or equal not 0, what happened about this? Then what is the solution? So now I am going to discuss about that. If determinant A equal not 0, it means it is non-singular matrix. Non-singular matrix. Okay, and hence we can say A inverse exists. Okay, so see A inverse exists, and we also can say if system has one or more solution, then it is consistent. What is the meaning of consistent? Consistent meaning system has one or more than one solutions. Okay, and system is inconsistent, then the meaning is no solution. Okay, so if A inverse exists, then we can say the system is consistent and has a unique solution. Okay, then using x equal to A inverse B, we can solve the equation. Okay, and find out the value of x and y, or it is triple then x, y, z. So when we can find the unique solution, if determinant A is 0. Okay student, now very important point, if we got the value of determinant A equal to 0, then what we can say? So what we can say, no solutions or infinite number of solutions. So it may be no solution or infinite number of solution. Infinite number of solutions. Then what we have to do? First we check the product of adjoint A into B, and we check this product. If we find the result is 0, then we can write answer only no solution. If no solution, then system is inconsistent. Okay, now if we got the value of this adjoint A into B equal not 0, then what we got is if it is constant A is equal not 0, then no solution, and inconsistent equal not for no. Okay, now if it is equal to 0, then there may be infinitely many solutions. And if many solutions, then system is consistent. And if system is consistent, then maybe dependent equations. Okay, dependent equations. What is the meaning of the dependent equations? So dependent equation means when we solve the three equations, we can find the value of x and y in terms of z. That z equal to t, then x will be found in the terms of t and y will be found in terms of t. Okay, it is for examples. So it is the meaning of dependent equations. Now we can see the third one. Here, special case, if b equal to 0, 0, 0, then equations are homogeneous. Okay, then what happened? If here is this case, we check first determinant A equal not 0. Okay, then we write directly x equal to 0, y equal to 0, z equal to 0, and these are known as system has trivial solution. Okay, now if we check here determinant A equal to 0, then again we can say system has infinitely many solutions. Okay students, so today what I have described you, according to that you can do so many questions from your syllabus. Now students, in the next lecture I will tell you the solution of linear equation by determinant method or Cramer's method. Okay, so you have to wait for same. Okay, so student, thanks you for watching.